and then it's decreasing. So what would we expect to see on our curve? Same type of thing we saw before, isn't it? Okay. So now, let's see. Then you had average product, you said? Okay. How did you compute average product? So 10 divided by 1 is 10. 30 divided by 2 is 15. 30, 50. Am I doing this right?
No.
The average, the marginal?
You take, oh yeah, good point. So 1 would be 20. Because 60 divided by...
That's right. Okay. Sorry about that. Just a little slip of my thoughts there. So that would be 20 here, because 60 divided by 3 is that. 4, yeah, I kind of got off, didn't I? This is what happens when I don't have a lines. Okay, 2 divided into 30 is 15. 3 divided into 60 is 20. 4 divided into 100 is 25. What's the next one? 5 divided into 130? Yeah, but I just thought I'd have you guys think it up. Is it 25 again? I thought it was 26. Okay, we got 25 on here. 6 divided into 150. Let's see, 6 goes into, that's be 225. Okay. 7 divided by into 165. And yeah, Angie has 23 and 4 sevens. Okay. 175 divided by 8. She has 21 and 7 eighths. Okay, and 180 divided by 9 is 20. Okay, so the average product. Now, what were you looking at on this? Do you want to explain now the rest, now that I've got that much of it?
It's the same.
Because you've got some graphs there, and I just want to...
I'll laugh at Allison. We just did the same graph as we did on the first one.
Okay, so you did a product, okay, and then you did, was it marginal product there?
Oh, for the second graph, yeah, we had a marginal product and average product.
And then an average product. Okay, now, we expect to see on the product labor to be about the same thing we had before, something that is concave up and then concave down. Has anyone gone so far now to do that scatter plot?
I have a question.
Yeah.
On the point where it changes from increasing to decreasing on this chart, that would be your inflection point, right?
Yes. There would be your, what's the other name we gave to it on Tuesday? Point of what? Diminishing returns. So for this, it means what? Okay. The window settings, I'm going to have to expand the window a little bit because we went up to 9. I'll make it 10. And for this one, we went up to, what was that again, 180? So better make it about 200. There it is. Okay, same idea, but if you're analyzing this, we actually have the rate of change of the rate of change. The rate of change of the marginal product is increasing and then decreasing, and so there is a point in here, yes, where we would have an inflection point. The inflection point is a point where what happens on the function? What changes? Concavity. Okay, concavity changes, and so we change from being concave up to being concave down on this. What do we expect to see on the marginal profit? Now let's take a look at this. Look at the data. If I do marginal profit, it should be concave down everywhere because we go to a maximum. So if we analyze this, we should have a derivative, a first derivative that gives us an extrema somewhere around the 4 to 5 area. Looks like exactly at 4 in this case, okay? So what we have to do on our graph would be then to put that data in, and then we would see that we'd have something that's concave down. But I think what you did was you compared the marginal profit with the average profit, and you were seeing a connection between those two. Okay, so if we wanted to duplicate that with this, I'd come over here and do, I'm going to say marginal product, and I'm going to say over here average product, and I'm going to put those values in. Oops, and what values do we have? Okay, so I've got, I'm just going to enter them in that I've got here, 0, 10, 20, 30, 40, 30, 20, 15, 10, and 5. And for average product, we'll put those in too. What do we expect to see for this? Let's see, 23, what did I do here? This should be, I missed a 10 up there? Oh, I sure did. Okay. There we go. And down here, we're going to do 23 and 4/7. I'm going to have to say equals 23 plus 4 divided by 7 with a period behind it in order to get it to be a decimal. And there it is. And I'll do the same thing here. Remember, the decimal point, any work is going to make it an approximated value. And then we finish up with 20. Now, I'm not sure, I've never tried this before. On that same page that we did the other one, I'm not sure I can do more than one graph on there at a time. But what I can do is go to graphs and geometry. I'll go through this kind of slow. I have to go into graph type. And a graph type would be a scatter plot. Okay, I'll do that again. Menu, graph type, and scatter plot. That's how I can get a scatter plot. So I could have done for the other ones too. I just chose not to. Okay, then I have to decide what variable goes in here, and if I press the variable key, and again, if you're used to seeing this, you know to just follow the red. On the gray one, it's on the other side of the screen, or of the handheld. Our labor is our input. Tab down. Tab down. Let's try that again. Labor. Okay, and then marginal product. I've got to change my window, not surprising. My window, let's see, what's it going to from 0 to what? Is it 10? Okay, we'll make it 12. And my output, I know I don't have negative, we'll put -1 to, what was it? Marginal product. The marginal doesn't go that much because we're only counting the difference between. What's the marginal maximum there? 40, so we'll make it 45. Oops. I'll count those by 5s. Okay. Is it what we expected? Okay, this is just a scatter plot now. This isn't the actual curve. If I want to put the other one with it, I'm just going to superimpose the same thing here on top of it. I'd have labor, and now I want the average product. But I'm going to have the same icons, aren't I, for this? This is going to be pretty difficult to see. I'm going to change the icons, and let's see. Can I do that from here? Not from here. Okay. Well, we'll do this. Oh, it did it for us. Thank you. Okay. So there's the average there. Did we expect to see that? Now, one of the questions might be for what labor is your marginal the same as your average? And if I had a nice smooth curve through this, I would be looking at something right about here. Did you get into any of that? What were you? Was that what you were trying to go for? Okay, Allison's agreeing with you on that, Angie. So, that's but what are we doing? We're looking at derivatives on this. And so, take this information with you. Those of you taking Econ 2 next semester, take it with you. Anytime you hear the word marginal, I hope you think of derivative. And if you're looking at how fast the marginal output is changing, you're talking second derivative. Okay, that's how it all fits together. Okay, well, that was something that I hadn't intended to get into quite, at this point. But if we're talking about applications of what we're doing to what you're studying, how better apropos than this that we have it. So thank you, Angie, for bringing that in to us. If you have other problems, bring them in and let's look at them. Now, we can go through our own problems here. Again, we've got average cost, and average cost wouldn't be any different of a discussion than what we were looking at with average product. That's taking the cost and dividing it by the number of units. The only problem is we don't have the data to show us. We don't have the number of units and the cost that comes from it to show us. But what do we know about average? What formula or function can we build how would you compute average? Divided by number of units, yeah. We often overthink. And don't overthink this. If you want to find average, wouldn't you take the total, divide by the number of items that created it? And so we do the same thing. So we've got 5/10 n squared plus 10n plus 7200 divided by n. Now, what are we trying to do with this? Once we find what average cost is, then what? Nick, what's the problem asking us to do? How do you know that? What's in the problem that tells you that?
The level of production per unit, or will the average cost per unit be minimized?
You want to minimize average cost. Yeah. That's the key. That's what we're going to, we have some problems that say maximize. I was doing some problems with the Calc 1 classes today, and they're doing exactly the same thing. Again, you're studying almost the same thing each day, but for them, we had a problem of taking a circle and putting an isosceles triangle in it, and what maximize the area of the triangle? What size, what's the height on the triangle that maximizes the area of that? there's a little different approach to that. But we also had to key in on the fact